Our adaptation in our grant is the development of language. So we no longer call it a PBL lesson, but we call it a PBEL lesson, problem-based enhanced language learning. It has all of the characteristics of a strong PBL lesson with the addition of the content language objectives and adding the additional supports that students need to demonstrate both knowledge of content and development of language skills. And our goal for every lesson is to provide opportunities for reading, writing, speaking, and listening. So every day the students have an opportunity to do all of those 4 things in the lesson. So it's not just teacher talk or it's not just students working on a lab. It's interactive with high expectations for all students to participate. So this lesson was derived from a problem-based learning activity. And we started with a problem that was relevant to the students, in this case, demolition of the Cardinal Stadium. Our adaptation in our grant is the development of language, and the purpose of that is to develop the language students need to be able to talk about the content and use the words that professionals might use in that field. So we're further developing their language skills through the use of authentic problems.
So they will be able to not only develop language, but also they are stronger at the science content. We're asking them not to just tell us what they did, but they have to argue, provide evidence for what they did.
To begin the lesson, the students come in the classroom and we present them with the objective for the day. And the idea of that is letting them know what learning will be taking place for the day and to get them excited about what the opportunities are going to be and kind of the direction that we're going. How many of you have ever been on something like the Sea Dragon? Castles and Coasters? Is that where you went on it? Yeah, maybe Six Flags or something like that, or a state fair, they have them too. They're a lot of fun. Some people get sick on them because they swerve back and forth and back and forth. Well, the Sea Dragon up there is a great example of a pendulum. How many of you have heard of the word pendulum before? Raise your hand if you've heard pendulum before. Good, so we're all pretty familiar with it. That's a pretty complicated word, but we have a good description of it up there. It goes back and forth. You see the Sea Dragon there going back and forth. Well, specifically, one type of pendulum we're going to talk about today is called a wrecking ball. And you may have seen a wrecking ball in action before. You can see there's a picture of it on the left there. But we want to know what is a pendulum and how is a wrecking ball just like a pendulum. After we introduce the objectives of the lesson, we get into the vocabulary. As we mentioned, this is a language program in addition to a content program. So we focus on language that is relevant to the content and language that is important for the students to be able to use to explain their thinking and reasoning throughout the lesson. So we go through several of the vocabulary terms, we use them in context. So there's some words that go along with that. So if you look on the board up here, I've written them down so we can use them today. But all pendulums have a pivot. Does somebody want to describe to me what a pivot is? What do you think?
It's like what allows them to move.
Perfect, it's where it's attached, right? That's where it's attached. There's our pivot right there. And in an ideal world, it doesn't have any friction. That's why they said frictionless. It should be really smooth. You don't want it to bind up and stop that thing from swinging back and forth. So we have a pivot. So all pendulums have a pivot. A wrecking ball has a pivot. They also have a rod or a chain or something that connects the pivot to the bob at the bottom. It's kind of a fun word using the word bob, but bob is what it's technically called, the bottom part of a pendulum. In this case, you can see the bob there. And then you can see the chain that's connecting it, which we call the massless rod. Now, obviously, it does have some mass again, but that's okay. We're just talking about it in generalities. Okay, so some vocabulary for today. I'm going to leave it up here so that you can see it and talk about it as you're working with your group. So if you ever have a question, you're not sure what quite word you should use, you can look up here and take a look at it. And then we move into the experimentation phase. And as I mentioned, that starts with a problem, an authentic problem that students can connect to. And today's lesson was about redesigning the Cardinal Stadium using demolition. So we present the problem to the students in an authentic way and give them the resources and tools they need to speak about that lesson and speak about their learning so they can talk about what they're learning. So today we're going to use the language of analysis and vocabulary to use a wrecking ball. And we have an actual job that we're going to do today. So your table has been asked by Mr. Bidwell, the owner of the Cardinals, to help with some refurbishment at the Cardinal Stadium. So Mr. Bidwell has asked us to help him with his project. He wants to redesign the Cardinal Stadium. He wants to preserve the parts of the stadium that are functioning, the parts that are working still. So there's some great seats out there where you have a great view and you can see everything. But parts of the seats, not so good. So we got to help Mr. Bidwell kind of fix that a little bit. How can we, us as a company, analyze for and select the best characteristics of a wrecking ball so as to write a proposal for demolition that meets the criteria determined by the Cardinals? Your job is to only knock down the top 5 rows. Because remember, the Cardinals don't want us to destroy the entire stadium. They only want us to destroy the other ones. Once we introduce the problem, we move on to the experimentation, and we set it up in a way that is very similar to the scientific method, and the purpose is to help students understand how scientists approach a problem by setting up variables and constants and modifying one thing at a time.
Just begin. Alright, let's try the small one first.
So we want to take off 5 rows. Watch out.
We already started.
3, 2.
Wait, no. Oh, wait, yeah. We're starting at 2.
3, 2, 1.
Okay, to survive, because these are the exact same.
18.
What I find interesting is that medium had the highest amount. I thought large would get the highest amount because it's bigger.
Yeah, and it knocked down.
Well, medium has a surprisingly a larger average of how many blocks it knocked down.
At the end, they present a recommendation to the owner of the Cardinals for a contract to allow them to work on the demolition. So they're taking that authentic problem, they're taking the vocabulary that we've given them, they're using the sentence structures and the writing structures we provided them, and using that all together to come up with a final writing application where they are presenting the content that they've just learned in a way that other people might be able to understand.
We know that science writing can be complicated because we're looking for specific details related to the content of the lesson. We want to be able to assess that they understand the relationship between the height and the weight and the demolition of the Cardinal Stadium. Through modeled writing, we can coach them on how do you start a letter? What would be the best way to use this sentence frame? Here's how I would structure it. So in a sense, when we're modeling how to write, we're talking through language, we're talking about language. If a student has a question about which word to use or how to say things in a different language, this is how we model it. So in this way, when we're talking about language while we're writing it, we're able to assess for content apart from language, and we're able to model how to do something that is really high level and technical.